Okay, here we go with hints for homework sheet number 4. Now, number 1, straight line question. Best thing to do is to split this up into little bits. So find the equation of the L1, the perpendicular bisector. So perpendicular bisector means the first thing we need to do is we need to find the midpoint, which is this point here. Second thing we need to do is we need to find the gradient of PQ. Third thing is then find the perpendicular gradient. And then lastly, the fourth thing, use the midpoint and the perpendicular gradient into the formula y minus b equals mx minus a, and that will give you the red line. For the find the equation of L2, which is parallel to PQ and passes through the point 1, negative 2. So let's just say 1, negative 2 is there. So we're trying to find the equation of that line. So we've got the point on the line, tells us 1, negative 2. What's the gradient of the red line this time? Well, the gradient of the red line is just parallel to PQ, and we've just worked out PQ previously. So use your answer to part A and that point to get the equation of that red line. Once you've done that, then the next stage, let me draw this red line back in, and let me draw the original line in that we had. The third part is to find the point of intersection. Okay, that's relatively easy, that's just simultaneous equations with what you've done. And then part D says, hence find the shortest distance between the two lines. Well, if you look at my diagram, then this black line here, that's going to be the shortest distance. Remember in part A we worked out this midpoint. Okay, we've got this green point because that was the point that they gave you in part B. So if you just use the distance formula, which is the square root of x2 minus x1 all squared plus y2 minus y1 all squared, do that, you'll get the answer. Now, it's a wee bit more complicated because there's fractions involved, but see how you get on. Question 2, much simpler. Determine if the function is increasing. So if it's increasing, remember, then f dashed of x is bigger than 0. It's a positive number. So differentiate the formula. So work out f dashed of x, you know how to do that, and then substitute in the point 2. So work out f dashed of 2. Whatever that answer comes to, hopefully it's positive. Aye. Question 3, another bit of a monster question. Find the coordinates of the stationary points. So the first thing we're going to do is differentiate. F dashed of x equals, now I'll do this for you. I might have just realised there's a wee mistake in my question. I've written down, oh, wait a minute, have I done 2 or question 2? Is that what's happened? Sorry guys, right. So let's just ignore all that. There we go. Right, there's question 3. Right, sorry. So the first thing we do is we work out f dashed of x. Okay, and I'll do that for you. 3x squared minus 3. And you know that for stationary points, f dashed of x must be 0. So put this formula, 3x squared minus 3 equal to 0. Okay, so how are we going to solve that? First thing I would do is I would divide by 3's, that gets rid of the 3's, and then I would factorise into a couple of brackets, and that's going to tell me what the x numbers are. Once I've got the x numbers, the next thing I can work out is the y numbers. How do I do that? By substituting the x numbers back into the original formula. Now all we've got to do is, let's move that up a wee second, we've got to work out their nature. So as you get closer to the first answer and as you get further away, remember that's the x number you found here, right, you're going to draw the shape of the graph. So substitute the numbers into f dashed of x, and you should find it looks something like that, or maybe it looks like that. Anyway, you can do that part to find out if they're maximums or minimums. Last section, we need to put all of that together on a diagram. So work out where it crosses the y-axis. You know what that is, it's a number at the end. You've got your three places where it crosses the x-axis. You know the points where it turns. You can join them all up to get the shape. I'll let you do that yourself. You can do that. For the second part of the question, show that x minus 1 is a factor. Okay, that means we're back to polynomials. So we need a polynomial, 1x cubed, no x squared, negative 3x's and positive 2. Now we're going to put in here positive 1. Then we're going to go through our process, and hopefully we're going to get a 0 here. If we get a 0 there, then that means it's a factor. Once you've done that, excuse me, we take these 3 points here and we factorise them into a couple of brackets. So you'll have your 1, 2, 3 factors. And question 4. A circle has the equation x squared, you can see that. A second circle's got a centre of negative 2, 7. Right, but we need to know its radius. It says the radius is twice as big as the first one. So from this formula up here, we're going to use the gradient formula, the radius formula, as g squared plus f squared take away c. Now would you please note, last week a lot of people put the wrong number in. It's negative 12 that goes in there. So you're going to be doing take away negative 12. So just be careful with the signs. Once you get this answer, double it for this part of the question, and then substitute the centre into your formula, x minus a all squared, y minus b all squared equals r squared. In fact, I've just made a wee mistake, there's pluses. X plus a squared plus y plus b squared equals r squared. Question 5, recurrence relations. Now we know what u2 is, tells us in the question. So u3 is going to be 2/5 of u2 plus 10. So simply substitute that number in there. Why does it have a limit? Well, you know your little statement. Limit exists because, and then put your statement in. And then lastly, what is the limit? The limit is c over 1 minus m. So you're now going to substitute the c and the m into that formula. Try and do it without a calculator, because this one would be a non-calculator question. And lastly, number 6. We need to know when it's got no real roots. So no real roots. What's the condition for that? The condition for that is that the discriminant must be less than 0. Your b squared minus 4ac has to be less than 0. So identify your a, 1. Identify your b, negative 2. Identify your c, 3 minus p. Plug all of these into that formula, and you should get an answer, a nice wee simple answer coming out, that p is less than, well, you tell me. Okay, that's us.